transform is to get ourselves ready and to have a certain tools and to perform such a rigorous calculation. And if you have time in the handouts, you should see for each problem I provide two methods, method 1 and method 2. Method 2 is to use Laplace transform. So here I try to get ourselves ready for that one. So today and Friday I will keep this page here and do all the calculation over there. So in this way we can refer to the contents of the tables. So that will involve a little bit more writings. So we can start from this example. If we want to take the Laplace inverse of these functions, okay, so if we have the Laplace transform, we want to get the inverse Laplace transform. And so basically this one, the first step is to factorize the functions. Okay, so basically we want to factorize in a way we can, the bottom line is to show up, to do something, and such that we can, the form, the derived form can show up in the table. In this way we can directly apply the table. Okay, so look at table here. And so basically here we have the denominator usually is the linear function, the linear term, linear polynomial s minus a or s plus a. Or at most that is the second degree polynomial. So when we do the factorization, that is our goal. So and then we look at here, that is a multiplication of the three linear terms. So we simply factorize for each term. So here s plus 1. S plus 2 and S plus 3. And we don't know what is the coefficient, and we simply put into ABC. And we're going to determine the ABC using this one. Okay, so basically the two things are equivalent. So usually we determine ABC, you can try is this. Okay, the below is our scratch calculations. So basically you can factorize everything together, they multiply together. So A would be equal to A times S plus 2 and S plus 3 plus B, S plus 1, S plus 3, and C, S plus 1, S plus 2. Okay, so basically here that is our assumed fraction. Then we, to determine ABC, we simply put them together. So in this way, right now you can see, compare the numerator on the both sides of the equal sign, and simply we compare the coefficients, in the numerator as squared, S1, and S0. So from here, the left-hand side, the coefficient of S squared term is 0, and the one term, that is 1, and this is 3. Okay, so that simply is equal to individual terms we obtained from the right-hand side. Okay? Good? Okay, so here let me do these implementations. So here, let me do a little bit more scratch as the first example here. So the first one simply converted is the S squared plus 5, S plus 6. The second term is B S squared plus 4S plus 3. The third term is C S squared plus 3S plus 2. Okay, so I simply put into in details. And today my writing will be a little bit quicker, so try to catch up. In the meantime, you try to listen. Okay. So in this way, on the right-hand side, we simply collect the coefficients for each term. For x squared term, that is a plus b plus c. Okay, and for the linear term, s to the power 1, so that is 5a plus 4b plus 3c. Okay, for constant s to the power 0, so that is 6a plus 3b plus 2c. Okay, so 3 unknowns, a, b, c, and here we have 3 the equations we can solve with them. And so basically here we should be able to get the a equal to minus 1, and b equal to 7, and c equal to minus 6. Okay. Do you like this method? I think at least it works, and a little bit time consuming. And here there's 3 equations. I think you can just be patient and you can get it. Yes.
So where did the 0, the 5, and the 3 come from?
Yeah. So basically you can see on the right-hand side, the numerator is 5s plus 3, right? So that basically 0 times s squared plus 5s plus 3 as 0. So that means this is a coefficient. Got it? So 0, that is here. And the s1 is here, and s0 is this one. Okay? So this method works, and we have a better approach. So I'm going to show you another approach. In the meantime, when you write it, then you write the other approach using a different color here. So a different approach, let me write it up here. So the different approach, again, that is based upon the comparison. We start from these equations. Okay, we start from these equations. Let me rewrite this term here. So another approach is based upon these equations. Again, that is still based upon comparison of the numerators on the both sides. Okay, so let me rewrite here. So that means we require is 5s plus 3 equal to a s plus 2, 3 plus b s plus 1 s plus 3 plus c s plus 1 s plus 2. Okay, I simply write up the numerator on the both sides and to this one here, the same thing as we started point from here. Okay, this approach is working like this, and that's based upon the observations. To determine A, so right now we're going to determine A, B, C sequentially. Okay, so look at here. Right now we're going to determine A. If we want A to be there and have the other 2 B and C related terms disappear, I mean come down to 0. In this way, we can have only one, the A appear on the right-hand side. So keep this in mind. We want the B related and B and C related terms disappear. What we can do, you can see. B has for the B term, it involves this. For C term, it involves this. But A term doesn't involve this one. So in this way, if we would introduce the value of s equal to minus 1 on the whole equations, then the 2 terms disappear. So which means, look at here, using s equal to minus 1, then 5s plus 3 s equal to minus 1 will be equal to a times s plus 2 and s plus 3 and s equal to minus 1. That's it. The other two terms become 0, 0. Are we okay? Okay. So that is the thinking process, and we can further rearrange our thinking process in a more organized way, in such that we can reuse this kind of concept. So in this way, let me reorganize. So that means A is simply equal to, I move this term to the left-hand side, so that simply becomes 5s plus 3 s plus 2, s plus 3. And that is when s equal to minus 1, right? Are we okay? Okay, and furthermore, we want to be useful. Look at this one. This one, let me rewrite. Basically, this one becomes 5s plus 3 and s plus 2 and s plus 3. And let me multiply s plus 1 and divide by s plus 1. Okay, I do this on purpose. I'm going to explain it in 1 minute. So basically, this one equivalent to this. Okay, so based upon this one, let me rewrite. So that basically becomes s plus 1, s plus 2, s plus 3, and then multiply with s plus 1, so s minus 1. So let me define our original given function. Let me call that with f of s. Okay, so basically A is simply equal to f of s multiply s plus 1 when s equal to minus 1. So that is the useful information. So simply, A is this term, right? A is associated with s plus 1. So to calculate A, you simply multiply the both same sides with s plus 1. So let me do this one here. Based upon these equations, we want to determine A, you simply taking up, this is our Fs, and times s plus 1, and will be equal to have A stand out, and B plus 2 and s plus 1, plus C, s plus 3, and s plus 1. Okay, so the operation is this. We simply multiply the both sides with the associated numerator, that with A. Under this situation, you can see if we set up as value equal to 1, so when we set up as equal to 1, then this term 0, this term 0. So that means A is simply equal to this. Okay? And we can exercise how to determine B. To find B, the same concept, we focus on this term. We have B to stand out, then we multiply. We multiply the both sides with s plus 2, right? Okay, so in this way, this one is B to stand out the B term. So this is A, s plus 1 times s plus 2. So that is C, s plus 1, and this s plus 2. So this term is Fs and s plus 2, right? And have these the other two terms disappear, we simply set s equal to minus 2. So that means this term becomes 0, this term becomes 0. So that means B equal to this. You okay? Okay, then we can exercise to find C. So C is here, so we can have multiply the both sides with s plus 3. Okay, so right now we have such that one, and our goal is to determine C, to find a way to make the two terms disappear. Then that one we can set it up as equal to -3. Be good? Okay, so that is the way to do it. And then how to do the calculations. So here is a little bit more implementations. So implementation is this. So in this way, we have fs and given by this and multiply with s plus 1. So that basically becomes 5s plus 3 and s plus 2 and s plus 3 and second s equal to -1. So we simply plug in the s equal to -1 to the term here. So that becomes -2 and then 1 times 2. So that becomes -1. So a is -1. Okay, so therefore a value to the implementation is just something like this one. Okay, you can repeat the calculation, then you should be able to find the b very quickly. 7, and this one is -6. And this way, this approach is, once you get used to the process, it's very quick and very accurate. Okay, or otherwise you can go to the previous approach, and that also works. It really depends on your preference. Okay, down.